This is the Cortx dicom integration. Dicom is a very common file type in the healthcare industry, therefore we choose this. It will consist of two main parts. First of all, I will show the core components, and on the other hand, I will show the example. The core components has two main classes. The one is a configuration class. It can load and save configuration, and it can get keys, check if keys exist, and set keys. This is all of it. It's not that important. It's a singleton because every method is class method. The Cortx dicom class consists of much more functions. They have some constants. For example, content type, this is for S3 services. An index, this is for Elasticsearch. Some filter constants, and key schemes constants to store and show dicom data. The init function is quite straightforward. It needs only two engines. If you don't give those engines, the function can be created on its own. But if you have some additional features which you want to set up, this way you can do it. Or some features are supported via the configuration as well. We have a class method. This is apply filter. It works without instantiating Cortx dicom. It can filter HIPAA and GDPR and private keys. The filters can be applied together or separately because those constants works as switches. Another class method is describe. It creates from dicom file format convenient to Elasticsearch indexing. The next part is direct access to Elasticsearch engine. So this is only a property. The next function is get. It has a very interesting form because you can get via Elasticsearch expression, or you can get via object key and the bucket name. So, and for the Elasticsearch there is also an index available, so you can use more indexes at the same time. All those parameters has a defined precedence. You can read it here. And the next is the S3 engine, just the same as ES engine. This is a direct access property for it. The search function searches in the Elasticsearch database, so you can give a search expression and an index. Just find is a very important parameter. If you set it to true, this means that the function will retrieve only Boolean, true or false, whether there is some instance that confirms the search or not. Or if you give false, in this case it will return the bucket names and object keys for you to get those objects. Store is an easy function. You can give object name, but it's not necessary. Of course, you need an object, and you can do bucket name and index name. Bucket for S3, index for Elasticsearch, and allow overwrite is important because S3 allows you any time to overwrite. If you have the permission to write, you can set it to don't allow it. If you don't give object name, the system can create random object names. In this case, the system will never override existing files. S3 buckets gets the list of buckets. S3 get instance gets Python instance. So the name is a bit misleading, but it's not about AWS instances, but about Pickle instances. So it's because the instance. S3 objects get all object keys in a bucket. There are some private functions for content type, for index, for S3 location determination to interpret Elasticsearch results, and class methods. Private class methods are there to load filtering labels and making GDPR and HIPAA filtering. There is also a bucket validation function, object validation, and so on. And there is two more functions outside the classes. They are about to determine whether an ES or an S3 query was successful or not. Here is an example. In our example, there is someone who wants to store objects in a Cortx server. So earlier I tested whether or not our Cortx server is healthy. It seems everything is in okay. So let's see how it works in practice. So in the first step we load the configuration, and then we create the index and the bucket. Creating a bucket is tricky because S3 doesn't let you create a bucket if there is already one, so therefore this is here, this check. And we are loading some files. We remove HIPAA from the files, and we will show the results, how many HIPAA dangerous tags were there. And then we store the files. This is the first part. And in the next step we will give 15 seconds to the local Cortx server to have some work time. And after it is useful if you are using local machine. And after that we will demonstrate the differences between functions. The first is search, but in this case just find is true, it's the default value, so it will return a boolean. In the next case it will retrieve the bucket names and the object keys of the instances. And in the last part of the search section we will use get. In this case we will receive the instances. And at the end we will get a dicom file, but in this time not through Elasticsearch but through S3 direct query, because we will use object key and bucket names. And at the end we will make some cleanup. So let's see how looks it in the practice. So we select files. As you can see, about 18 fields are HIPAA dangerous. It will be deleted. So from 54 only 36 will be stored, and now it's everything okay. You will see here is the result of the search, and as you can see there is some virtual machine use. So thanks for watching. This is it.